Dear friends, in this class, let us discuss about the pitching moment in aerodynamics. So, what is meant by pitching moment, and how the pitching moment is fixed at the aerodynamic center, how the center of pressure playing the role in fixing the center pitching moment, and how the pitching moment is fixed at the how the pitching moment is constant at the aerodynamic center. So these points we will discuss one by one in this lecture. And first let us see in the case of symmetrical aerofoil what happens. So in the case of symmetrical aerofoil, both the aerodynamic center and the center of pressure lies at the same point. So that point is nothing but we say it is quarter chord point, means the distance from the leading edge to this point is nothing but 25% of the chord. So that is what we call it as quarter chord point. And in the case of angle of attack 0, the pitching moment also 0. That is because at angle of attack 0, the lift is 0. Since the lift is 0, which is responsible for generating the pitching moment. So in this case it is 0. Because of that, here we don't have any pitching moment. As the angle of attack increases, the lift also increases. So that is what we observe on the CL alpha curve. So because but center of pressure does not change. The center of pressure does not change because of the increase in the angle of attack. So generally increase in the angle of attack, the distributed forces also increases in the same proportion. So because of that reason, the center of pressure does not move away from the aerodynamic center. So that is only in the case of symmetrical aerofoil. So this, because of that reason, again the pitching moment is 0 in this aerofoil, and in this position. And again the angle of attack further increases, and but still the center of pressure and the still same at the same point. But the quantity of the lift increases. Quantity of the lift increases, but the center of pressure still lies at the same pressure, same point. So there is nothing at the quarter chord point. So this is because of the same proportion, the distributed forces. Again, because of the same proportion, it increases. So because of that, the center of pressure does not move away from the quarter chord point. So here in this case also both are lies at the same point. So because of that, for the cases of thin aerofoil and low speed aerofoils, the aerodynamic center and the center of pressure are fixed at the 25% of the chord. So nothing but quarter chord points. So this is verified from the experimental as well as from the theoretical calculation. It has been verified, both are lying at the this 25% of the chord, nothing but the quarter chord points. So in the case of unsymmetrical aerofoil or cambered aerofoil, so this is what the case. So here, as the angle of attack is 0, but it has some lift. So as in this case, we can say the angle of attack is 0, but it has some lift. So that produces some lift at the center of pressure, because at the center of pressure only resultant forces acts. So here the lift is very small. But it lies very much bigger in the aerodynamic center. So because of that, the moment is fixed. So the moment is nothing but lift into the distance, this x. So as the angle of attack increases, what happens? The lift also increases. The quantity of the lift also increases. So as the angle of attack, we can say that at this point, angle of attack is increases. So you can say that 5 degree. But lift increases. Because generally that is resultant forces acting at the center of pressure. So this as resultant forces only have been shifted to the aerodynamic center for our analyzing purpose. So that we know very well. So here both the quantities are same. Whatever the quantities are acting at the center of pressure, that is what have been shifted to the aerodynamic center. So, and the distance between this point, the distance between these 2 points and the lift, so constitutes the pitching moment. So that is what we see. Lift moment is nothing but lift into x. So if you take a moment lift into x, so that is nothing but if the moment if you want to have the constant moment, so we say because pitching moment is constant. If this is constant, this is constant, and in that case, what happened? The angle of attack, as the angle of attack increases, the pitching moment may come forward to the aerodynamic center. Previously, it was very much behind the aerodynamic center, but in this case, it is moving closer to the aerodynamic center, but still it is behind the aerodynamic center. But as the distance decreases, the quantity of the lift increases. So that because of the increase in the angle of attack. So because of that, again we are getting the same pitching moment. So pitching moment at the aerodynamic center. So in this case, still we can see that now the center of pressure is forward of the aerodynamic center, but as the angle of attack increases higher than this value, but it comes the center of pressure comes forward of the aerodynamic center. So but the lift increases, and the distance may be very small, but the lift increases. The distance may be small, but lift increases. Because of that, again the pitching moment same. Pitching moment remains constant in this case also. But as the center of pressure is ahead of the aerodynamic center, nothing but forward of the aerodynamic center. So this will produce the clockwise moment. So nothing like nose up pitching moment. And in this case, we can say the counterclockwise moments. Counterclockwise pitching moment is acting at the aerodynamic center in these cases. But in this case, so it will produce the clockwise pitching moment. So that generally we can say as the nose up pitching moment. So this is what about the how we are fixing the pitching moment at the aerodynamic center, and how it is moving forward and backward on the chord of the aerofoil depends upon the quantity of the lift, so which is responsible for producing the pitching moment. So thank you.